Hi everyone, hope you're all well and you've done really well with the current unit on algebraic fractions and algebraic proof. I'm just going to start talking you through how the marks are awarded and how you work out each of the questions just so that you can do any corrections for anything you're not sure on, and hopefully these will help you if you have a particular area you struggled with that you'll then have for your target work. So if we start with question 1. Okay, whenever we want to simplify an algebraic fraction, we need to make sure that it's in its factorized form and as simple as possible. So if we have a look at the numerator, our starting point there is to recognize that x cubed goes into both terms. So we can factorize x cubed on the outside and then have x squared minus 4 on the inside. And then the denominator will also factorize with 3 on the outside of the bracket and x minus 2 on the inside. At that point, for having either the numerator or the denominator correct, you would then get 1 mark. Your next step is to work out that the x squared minus 4 is actually a difference of 2 squares, and therefore that will factorize again to give you x plus 2 and x minus 2. Okay, hopefully recognizing then that something will cancel out on the numerator and the denominator, which is the x minus 2, so another mark at that point. And therefore your simplified answer would be x cubed brackets x plus 2 all over 3 for the third mark. If we then have a look at question 2, so for part A you needed to show clearly that x plus 5 in one bracket multiplied by x minus 5 in the other bracket is equivalent to x squared minus 25. So remember, that's your identity symbol there, the triple equals. It just means it will work, okay, for any value of x at that point. The only way to show that is to actually expand your brackets. So to get the mark, you needed to have x squared minus 5x plus 5x minus 25, which we know then simplifies to x squared minus 25. Without the minus 5x and the plus 5x, you don't get that method mark. And then for part B, you needed to factorize fully. So the numerator will factorize to give you 3x minus 4 and x minus 5, which you can use your cross method to work out. And you obviously know the denominator is going to be x plus 5, x minus 5. They gave you that in part A. So you get a mark for the numerator being factorized. A mark actually if you've got 3x and x as your two brackets, and then two numbers that multiply to make the positive 20. Even if they were wrong at that point, you'd get the method mark. Then if you write it out, you'll recognize the x minus 5 on both the numerator and the denominator will cancel out, giving you a final mark for your answer of 3x minus 4 over x plus 5. Okay, if we have a look then at question 3. So on question 3, the denominator is the easy one to factorize, so it has a common factor of x with a single bracket with x plus 3 in it. So a mark for getting that one correct. And then you can use your cross method to factorize your numerator. That will then give you 5x minus 4 and x plus 3. Okay, so a mark for that one. Write it out in its fraction, and then you'll recognize that x plus 3 appears on the numerator and the denominator and therefore will cancel out, leaving you with 5x minus 4 over x for the final mark. If we then have a look at question 4, so on question 4, we are subtracting fractions. So adding and subtracting fractions, we always need to have a common denominator. The easiest common denominator, if you think about the 2x times table and the 3x times table, is in fact 6x, although some of you may have used 6x squared, okay, which will still work. You'll just need to simplify fully at the end. But the lowest common multiple of 2x and 3x is 6x. So a mark if you have a common denominator of 6x or 6x squared will get you the first one. And then you need to obviously find the correct numerator. So for the first fraction, you multiplied everything through by 2. And for the second fraction, you would multiply everything through by 3. So therefore getting a second mark at this point. If we then write it as one fraction with a common denominator, we need to then expand our brackets and simplify, giving us a final mark for 2x minus 7 all over 6x. We then have a look at question 5. So on question 5, we need to add fractions again, so we need a common denominator. This time we are looking for the fact that the only way to get a common denominator is to multiply the two denominators together. So if you have the a common denominator of m plus 1 and m minus 4, you get your first method mark. You then need to obviously work out your numerator. So the first fraction would be multiplied by m minus 4, and the second fraction would be multiplied by m plus 1, and then we write it as one common fraction with that common denominator to get the next method mark. You then want to expand your brackets, so you end up with 5m minus 20 added to 6m plus 6, okay, over that common denominator, which we don't want to expand. We want to leave it as simplified as possible, getting our third mark. And then if you simplify your numerator, you will end up then with 11m minus 14 over the double brackets, okay, so you can leave it in that format. If we then have a look at question 6, so we're now going to divide by our fractions. Remember, you can use the fact that we keep the first fraction the same, we flip the second fraction upside down, and we change the divide to a times, okay, and then we simplify it. So h times 5 will give me 40, c to the power of 7 d cubed over, and then 15 times 6 will give me 90, c squared d to the power of 6. We get a mark for that one. And then we just need to simplify it fully. So 40 over 90 will simplify to 4 over 9. Our c to the power of 7 over c squared. Okay, so remember you're subtracting the powers at that point, will give you c to the power of 5, and then we've got d cubed over d to the power of 6, so we can cancel out d cubed from both, leaving us with d cubed on the bottom. Now you actually get the final 2 marks there for each part that you've got correct. So there are 3 things to have correct there. The 4/9 is one of them, c to the power of 5 is one, and d cubed is one. And each one you get wrong, you would then deduct a mark, okay? But that is your final answer to get those 3. We then have a look. Question 7. Okay, so question 7 and 8 are quite similar, but question 7 you only had to get part way through rather than fully solving it. So again, we need to add our fractions, so we need a common denominator, which means we're going to multiply the x minus 3 by the x minus 1. And then we need to get the correct numerator. So we're looking for this bit here, so 2 brackets x minus 1 added to one lot of x minus 3 for a mark over our common denominator. Expand all your brackets out and then simplify as much as possible, and we end up with this equation at the top on the right hand side. And then we don't like the fact that we've got an equation with a fraction, so we're going to multiply both sides by the denominator, giving us 3x minus 5 is equal to x squared minus 4x plus 3 for the next mark. And then in the question, it wants us to have an equation equal to 0. So we subtract the 3x from both sides, add 5 to both sides, and we end up with what they wanted. Okay, so just so you can see where that one comes from. Question 8 then, again is very similar to 7, but you will have to solve it at the end. So you'll have to go a little bit further than what we did here. So our starting point is to get a common denominator again, so x plus 4 and x minus 2 by multiplying the 2 denominators together. And then we also want to write it then with having the correct numerator. So a mark for the correct denominator. The second mark then for having one single fraction where you've got the numerator all sorted and correct. Then expand your brackets, so that will give us x squared minus 2x plus 7x over 28, and the denominator x squared plus 4x minus 2x minus 8, and simplify that as much as possible. And then we've got an equation with a fraction, so I don't like that. Therefore, I'm going to multiply both sides by the denominator. So that will give me x squared plus 5x plus 28 equals x squared plus 2x minus 8. If you didn't simplify it and you've got these two equivalent to each other, you still get that method mark at that point. And then we need to simplify to try and solve. So minus x squared from both sides makes it look a lot easier. Then we've got an equation with an x on both sides, so we always get rid of the smallest number of x's first. That's going to leave us with 3x plus 28 equals minus 8. Take away 28 from both sides and divide by 3, and you get a final mark for the correct answer of x equals minus 12. Then we start having a look at some of the proof questions. So question 9, we know that c is a positive integer and we need to prove this is an even number. Well, realistically, this is a proof question also using your knowledge of simplifying algebraic fractions. So your first job was to factorize. The numerator has a common factor of 6c, and therefore in brackets c squared plus 5, so you get a mark if you manage to get that one. The denominator has a common factor of 3, there, and inside the brackets c squared plus 5, and a second mark for that one. Hopefully you recognise then the c squared plus 5 will cancel from top and bottom, leaving us with 6c over 3, which will simplify to 2c, and you just state then that 2c, because it's a multiple of 2, it would be an even number. Okay, so for the third mark on that one. Question 10. Okay, so question 10 was quite difficult. There's a lot going on in this particular question. It is a show that, therefore a prove question. However, it's again using your vast knowledge of algebraic fractions to be able to do this. The easiest way to tackle this question before you start trying to multiply anything together is to factorize everything as much as possible. So my 2w plus 4 will factorize to give me 2 brackets w plus 2. The denominator w squared minus 25 is a difference of 2 squares, so that will factorize to give you w plus 5 and w minus 5. You get a mark at that point. The second fraction, there's nothing that will simplify on the numerator, but the denominator, you can use your cross method to factorize. You get w plus 1 and w plus 2, so a mark at that point. And then the last expression there, again, you can use your cross method to factorize, and you get 3w minus 1 and w minus 5 for the third mark. If you then multiply that all together, so remember it's 2w plus 2 multiplied by w plus 5. The last part is a fraction. Remember, it have a denominator of 1, so that enables you to multiply all of the numerators together and then multiply all of the denominators together. Then you'll see I've rewritten the order of it so you can see what cancels. So we've got a w plus 2 on top and bottom, that will cancel, a w plus 5 on top and bottom, that will cancel, and a w minus 5 on the top and bottom, that will cancel, leaving us with 2 brackets 3w plus 1 over w plus 1. That gets you the fourth mark. However, in the question, it wanted it in the format aw plus b over cw plus d. So you had to expand your brackets to give you 6w plus 2 over w plus 1 for the fifth mark. That is quite complicated, but it is a fact of making sure that everything is as factorized as possible before you start on that one. Question 11 then, much more of a standard proof question. So to be able to prove that that expression is a multiple of 3, you need to correctly expand your brackets. So your starting point is expand the first set of double brackets. You should get 5n squared minus 5n plus 3 minus 3. And therefore, you're allowed one error within that to pick up the first mark. If you then have that fully correct plus the second bracket, so n squared plus 2n on the end, you get the next mark. You can then simplify that. So your 5n squared plus n squared gives you 6n squared, minus 5n plus 3n will give you minus 2n, plus 2n will cancel out completely, and then you've just got the minus 3 left, so a mark at that point. And to show that it is a multiple of 3, you had to factorize the 3 on the outside, and therefore you state it's a multiple of 3 for the fourth mark. Okay. Question 12 then is another proof question. However, you are proving it using your knowledge of adding and subtracting algebraic fractions. So we know they need to have a common denominator, but they've given you the common denominator in the question, so you know what you're aiming for. And therefore on this one, you need to have the correct numerators. So 3n plus 5 and n minus 1. Take away 3n squared, or 3n times n. Then write it as one common fraction with a common denominator, and expand all of your brackets, and then when you simplify it, you will end up with the correct answer. So you do need it in fully expanded format to show that it gives you the answer in the question. Just writing down 2n minus 5 over 3n brackets n plus 1 doesn't score you any marks, because remember, they gave you that in the question. And then lastly, question 13, we needed to show that this particular fraction is a square number. Now, it already has a common denominator of 2, so we can just write it as one fraction. Okay, giving you your first mark. Then expand the brackets, and you will recognize that the minus n plus n will cancel out, leaving you with 2n squared over 2, which will simplify to n squared, and you just need to simply state that n squared is a square number. Okay, I recognise this is quite a challenging topic for you to try and get your heads around whilst you're learning at home. All right, so well done for all the time and effort that you have put into this one. If you've got any questions that you're not sure on, then please let me know. But there is a Google form for you to fill in for me now so I can see how you got on in terms of ragging each of those questions, and then I will set you a target for you to complete in the next lesson. Okay? Any problems, let me know. All right, take care.